Hello AP Scholars. These are the video notes for day 6. They're preparing us to work on slope fields and differential equations and solving differential equations by separating variables. So this is the problem that you were given for over the weekend. It gives us a differential equation here, dy dx equals x to the fourth times y minus 2. The first thing it asks us to do is to sketch the slope field for the 12 points indicated. So this differential equation gives us the slope, the equation that will help us find the slope for any x and y value. So to sketch the slope field, all we're going to do is plug in x and y. Let's start with this vertical set of points. For those points, x equals 0. So if I plug it in to dy over dx, I get 0 to the fourth times y minus 2. Well, it doesn't matter what y is. No matter what, this is going to end up equaling 0. So we're going to draw in a slope of 0 at each of these points. Okay, so that was pretty straightforward, getting values for x equals 0. Now let's take a look at x equals 1. If we plug in 1, we'd have 1 to the fourth, and then y minus 2. Here we're going to have to plug in individual y values. So let's start with this point with the coordinates 1, 0. So now I'm going to plug in 0 for y. So 0 minus 2. So this ends up being 1 times negative 2, which is negative 2. So we're going to estimate, draw an approximation of a slope of 2 here. Sorry, negative 2. That might be too steep. Let's try this again. Okay, so we're going to say that's negative 2. Now let's plug in a different y value. So instead of y equals 0, we're going to do 1 for this point here. So 1, 1. So this gives us 1 times negative 1, which is negative 1. So this is going to be a little less steep, but still negative. Okay, then let's plug in a y value of 2. So 2 minus 2 gives us 0, so the slope here ends up being 0. Now, this is an interesting one to think about. For any time that y is equal to 2, we are going to get, so let's look at dy dx, we've got x to the fourth. If y equals 2, we're going to end up with 2 minus 2, which gives us x to the fourth times 0, which will always be 0. So we can actually draw in a slope of 0 everywhere where y equals 2. Okay, so let's finish off these points where x equals 1. Looking here, we know our y value is 3. So 3 minus 2 is 1, so this is a slope of 1. So this is our first positive slope. We want it to be at about the same type of steepness as this point down here, because this is positive 1 and this is negative 1. Alright, now let's go over to x equals negative 1. So we're going to plug in negative 1. We're doing this set of vertical points here. Negative 1 to the fourth times y minus 2. Well, negative 1 to the fourth is always going to simplify to positive 1. So we're back here with the 1 times y minus 2. If y is 0, like in this first point, we get 1 times negative 2, which is negative 2. So it should be the same slope as the slope we had here. So we're going to draw that in. Then take out 0 and plug in 1 for y. We get 1 times negative 1, which is negative 1, so a little less steep, but still negative. We've already done this one. The final one, we're plugging in y equals 3. So this ends up being 1, just like the other slope right there. So that is our slope field. We're now done with a. Interestingly, this problem is worth 2 points, and the first point is for correctly finding all the points where the slope is 0. So you would need to get all of these correct as having a slope of 0. That would be the first point. And then the next point is for getting this and this positive, and then showing that these other points are negative slopes. All right, let's move on to part B. Part B says, while the slope field drawn in part A is drawn at only 12 points, it's defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are negative. So here we just need to describe what's going to produce a negative slope. So let's go back to thinking about what things looked like when we were plugging points in. Just give us a little more space. We saw that it didn't matter if x was positive or negative, and it didn't matter because it's being raised to the fourth. A negative number raised to the fourth is going to become positive. A positive number raised to the fourth is also positive. So we know that for dy dx, this x to the fourth is always going to generate some sort of positive number. So the slope sign really depends on this y minus 2. If y minus 2 is negative, then the slope will be negative. So you want to say something for b like if y minus 2 is negative or less than 0, then dy dx, or the slope, will be negative. Oop, didn't mean to go to the next page. So it'll be negative. You could also word that as if y is less than 2, then the slopes will be negative. I got that just by adding 2 to both sides. So that would get you a point for B. All right, let's clear the page now and take a look at part C. So part C says find the particular solution y equals f of x to the differential equation with an initial condition of f of 0 equals 0. So we know that we have a point at 0, 0, and we're going to have to use that at some point in the problem. It's asking us to find f of x, or the original y. That means we are going to have to integrate. So we were given dy dx equals x to the fourth times y minus 2. We cannot integrate this right now because we have x's on both sides and y's on both sides. So the first thing we have to do is separate our variables. That's the key step here. So I'm going to multiply dx to both sides. And so now I have dy equals x to the fourth, y minus 2 times dx. And now I want to move y, so I'm going to divide both sides by y minus 2. So I get dy over y minus 2 equals x to the fourth dx. Okay, I'm going to rewrite this so it's a little easier to integrate. This is equivalent to 1 divided by y minus 2 dy equals x to the fourth dx. So we're going to integrate this on both sides. And this is a minus 2. dy equals the integral of x to the fourth dx. Okay, normally we would use u substitution here because we have a function within a function, but the derivative of y minus 2 is just 1. So nothing's going to change here if we did u substitution. Du would still equal dy, so we can just proceed as if it was 1 over u. If you want to use u substitution, that's fine. We would think of this as 1 over u du, because the derivative of this is just 1 du. So dy equals 1 du. And then we have this equal to the integral of x to the fourth dx. Well, we know the integral of 1 over u is the natural log of u. I'm going to create some more space for us by clearing this page. So we have this equation, and then we said this integral is going to be the absolute natural log of the absolute value of u. And this is going to be x to the 5th over 5 plus c. Remember, we need a c on one of these sides. I'm going to substitute back in so that this is the natural log of y minus 2 equals 1/5 x to the 5th plus c. All right, now in order to solve this, or to get y alone, we're going to have to exponentiate. So I'm going to do e to the natural log of y minus 2 equals e to the 1/5 x to the 5th plus c. All right, now I know that e and the natural log will cancel, leaving me with y minus 2 equals e to the 1/5 x to the 5th plus c. Now remember, rules of exponents. If I have a base like x to the a times x to the b, I get x to the a plus b. But it also goes the other way. If I have two things being added in an exponent, I can separate them into two different parts with a base to the a times base to the b. So we're going to do that here. We have e to the 1/5 x to the 5th. And then instead of leaving this as a plus c in the exponent, we're going to change this to e to the c. And then we have y minus 2 over here. Now remember, e to the c is just a constant. So I'm going to change that and just call it c, big C, or like C1, to recognize that it's a different constant than we had over here. So we have C1 times e to the 1/5 x raised to the 5th, and y minus 2 over here. I'm going to add 2 to both sides. Y equals c, or C1, times e to the 1/5 x, 1/5 x to the 5th. Now I need to solve for my constant, and I'm going to have to use my initial condition here, f of 0 equals 0. So I'm going to clear the page again so we have room to work. So we said we had this equation, and now we're going to plug in the point 0, 0. So y equals 0, and our x value is 0 raised to the 5th plus 2. Okay, so we know 1/5 0 raised to the 0, 1/5 0 raised to the 5th will be 0. So this is 0 equals C1 times e to the 0 plus 2. E to the 0 we know cancels to be 1. So we really have 0 equals C1 plus 2. That means that negative 2 is equal to our constant. So our full equation is y equals negative 2 e to the 1/5 x to the 5th plus 2. Okay, so let's just quickly talk about how you earn points on this problem. This problem was worth 6 points. So any free response problem that is broken up into one part where you're solving a differential equation will usually earn you somewhere between 4 and 6 points. It is the majority of the problem. So the first point in this problem was earned if you separated the variables. So if you got to 1 over y minus 2 dy equals x to the 4th dx, you earned 1 point. The next point came from taking the integral, or the antiderivative. So if you integrated that correctly, you actually earned 2 points. So if you knew that giving this an integral was going to result in natural log of the absolute value of y minus 2 equals e to the 1/5 x to the 5th plus c, plus c, you actually earned 2 points here, plus 2. for the antiderivative, taking the antiderivative and doing it correctly. Then you actually get a point just for knowing that there's a constant that needs to be solved. So moving this down and solving for it gives you 2 points. One for acknowledging that there's a c, that gives you a point, and then actually figuring out what it is using this initial condition gives you a point. Then plugging it back in and having a final solution gives you a point. So if you don't separate the variables in the first step, you get no points for this problem. If you forget about c, you can earn a maximum of 3 points. If you don't get to quite the final answer, you could still earn up to 5 points along the way, as this problem, or subset, part C, was worth 6 points total. So we'll take a look at more differential equations and slope fields in class on Monday. If you'd like to see what the AP graders see when they're looking at this problem, you can, on the back of your note sheet, see how the points are distributed. So you can see A is worth 2 points, B was worth 1 point, and C was worth 6 points. Come ready with questions for class.